This is the first lesson for Chapter 6. Chapter 6 is all about inequalities and then how they are used in geometry. So the first slide here is properties of inequality. If you use any of these, you're just going to say property of inequality. You don't have to tell me which one it is. It's just accepted that that's a property of inequality. So if we're using these in a proof, which we're not doing today, again, if your reasoning is one of these, then you're just going to say properties of inequality. So in the first one, you'll see A is greater than B and C is greater than or equal to D. So A and C are the big things, and B and D are the small ones. So what this is saying is if you take the sum of the bigger ones, it's always going to be greater than the sum of the smaller ones. So I think you can kind of get that idea. It's not addition property of equality. You're not adding equal things to both sides. Okay, in the next two, these are actually ones you've done before when you did them in algebra. Notice here it says if C is greater than 0. So if C is greater than 0, that means C is a positive number. And what that is saying is if you multiply both sides by a positive number or divide both sides by a positive number, then what was bigger before will still be bigger in the result. Then we have this one over here where if C is less than 0, now C is a negative number. And you had done this before in Algebra 1 and should have discussed why in Algebra 1 this happens. If you multiply or divide both sides of an inequality by a negative number, then you need to flip the inequality. So you'll see I did that here compared to the original. So that's just a property of inequality. The bottom inequality down, or property, excuse me, down here is, it's kind of like a transitive, but not really. It's not transitive because it's not equals. But if A is greater than B and B is greater than C, then it should follow that A is bigger than C because it was bigger than it was before. And the last one here we actually use quite a lot in geometry. Notice again if C is greater than 0. If A, let's just say, is made up of B and C, okay, then A is going to be greater than B. The whole is greater than the part, okay? And I think you'll see where that comes into in geometry. If we have a whole segment and it's made up of two little segments, the whole segment is going to be greater than either part of the segment. In the next slide, we have a few examples. So what I'd like you to do is push pause, work through these the best you can, come back and I'll explain them. All right. So you see I have the answers here. This is using that property of inequality. If RS is larger than, smaller than ST, okay, but then here's ST and that's smaller than RT, you can see this is the biggest, then it goes to here, then it goes to here. So when you're comparing these two, RT is going to be greater than RS. And again, that's using this property of inequality right here. In the next one, PQU is made up of PQT and TQU, angle addition. So this is using that idea that the whole angle is bigger than either of the parts. So the larger is going to be greater than either part. And again, the property of inequality that is using is this bottom one down here. All right, again, I'd like you to try these true or false. And when you're done, push pause, try them. And when you're done, come on back. All right, over here we have that. Sorry. XY is made of YZ and 5, so we know the whole has to be greater than either of its parts. So XY is going to be greater than YC. That's true. In number 2, it's comparing B and C. We don't know anything about B and C. They could be equal. This could be true, but maybe C is bigger. So this one's going to be a false because we're not sure that this is definitely going to happen. In number 3, the same idea. The whole is going to be greater than either of the parts. But if you look at the inequality, that's saying the little bit of K is going to be greater than the whole angle. That's not going to work. That's false. In the last one, it's an algebraic example. We know that in order for this to be true, y has to equal 8, and y is definitely not bigger than 10, so that's also going to be a false. There's one more theorem here, and we can prove it pretty easily. Please remember this statement in blue I have here, exterior angle of a triangle. We did this back in maybe chapter 3, that angle 1 is equal to angle 3 plus angle 2. Well, knowing that from our previous examples, we're going to know that angle 1 is going to be greater than either of the parts. So angle 1 is going to have to be greater than angle 2, and angle 1 is greater than angle 3. We're not really sure how 2 and 3 work out comparing to each other, but we know that angle 1 is bigger than either of the parts, and that's called the exterior angle inequality theorem, if you need that. All right, make sure to check Canvas for your homework assignment, and that concludes the lesson on 6-1.